The dead coming back to life sounds scary, but for scientists, it can be a wonderful opportunity. Of course, we're not talking about zombies. Rather, this particular opportunity came in the unlikely form of a large, slow-moving fish called the coelacanth. This oddity dates back 360 million years and was believed to have died out during the same mass extinction event that wiped out the dinosaurs 65 million years ago. To biologists and paleontologists, this creature was a very old and fascinating, but entirely extinct fish, forever fossilized. That is, until 1938, when Marjorie Courtenay Latimer, a curator at a South African museum, came across a prehistoric-looking, gleaming blue fish hauled up at the nearby docks. She had a hunch that the strange 1.5-meter-long specimen was important, but couldn't preserve it in time to be studied and had it taxidermied. When she finally was able to reach J.L.B. Smith, a local fish expert, he was able to confirm at first sight that the creature was indeed a coelacanth. But it was another 14 years before a live specimen was found in the Comoros Islands, allowing scientists to closely study a creature that had barely evolved in 300 million years.
Yes, a living fossil.
A living fossil. Decades later, a second species was found near Indonesia. The survival of creatures thought extinct for so long proved to be one of the biggest discoveries of the century.
Zombie fish?
But the fact that the coelacanth came back from the dead isn't all that makes this fish so astounding. Even more intriguing is the fact that genetically and morphologically, the coelacanth has more in common with four-limbed vertebrates than almost any other fish, and its smaller genome is ideal for study. This makes the coelacanth a powerful link between aquatic and land vertebrates, a living record of their transition from water to land millions of years ago. The secret to this transition is in the fins.
So tired.
While the majority of ocean fish fall into the category of ray-finned fishes, coelacanths are part of a much smaller, evolutionarily distinct group with thicker fins, known as lobe-finned fish. 6 of the coelacanth's fins contain bones organized much like our limbs, with one bone connecting the fin to the body, another 2 connecting the bone to the tip of the fin, and several small finger-like bones at the tip. Not only are those fins structured in pairs to move in a synchronized way, the coelacanth even shares the same genetic sequence that promotes limb development in land vertebrates. So although the coelacanth itself isn't a landwalker, its fins do resemble those of its close relatives,
Yeah, g'day.
who first hauled their bodies onto land with the help of these sturdy, flexible appendages, acting as an evolutionary bridge to the landlubbers that followed. So that's how this prehistoric fish helps explain the evolutionary movement of vertebrates from water to land. Over millions of years, that transition led to the spread of all four-limbed animals, called tetrapods, like amphibians, birds, and even the mammals that are our ancestors. There's even another powerful clue, in that unlike most fish, coelacanths don't lay eggs, instead giving birth to live young pups, just like mammals. And this prehistoric fish will continue to provide us with fascinating information about the migration of vertebrates out of the ocean over 300 million years ago, a journey that ultimately drove our own evolution, survival, and existence. Today, the coelacanth remains a symbol of the wondrous mysteries that remain to be uncovered by science. With so much left to learn about this fish, the ocean depths, and evolution itself, who knows what other well-kept secrets our future discoveries may bring to life?